Could you hear me? Great.
Hi, can you hear?
Hi. I can hear you.
Hello, John. Can you hear me?
Yes, I can hear you. So did you talk to Rich? Great. Great.
Hey guys, welcome to the LWIG meeting. Zen couldn't make it, like his visa didn't get here in time, so I'm just sitting in, and I have like a sitting in co-chair as well.
Hi, everyone. My name is Jing. I'm the on-site volunteer and have to manage this session. And due to many reasons, so the two chairs are not here. Yeah.
So thanks. So let's get started.
I think Zhen, the co-chair Zhen, will remotely manage the session. So now we let Zhen to start.
Okay, so thank you so much, Jing and Rich. And I'm sorry that I could not make to Chicago this time. But I really found meeting Echo is wonderful. Actually, from some aspect, it's even better than I appear on site because I can be on screen, and it seems that you can see me more clearly than you can see me on site. So yeah, this is so let's switch to the topic right now. So so this is the LWIG working group meeting, and could you go to the next slide? Okay, this is Notewell. Please make sure that you are aware of the policies specified here. Next one. So, Jing, I think we found many takers, and we'll do the work on the collaborative editing page listed here, and make sure that you assign the blue sheet and which has been passed by Jing before the session. We have a GitHub. So we have a GitHub page right now, and thanks Custom for handling that for us. And we have moved some of the draft to the GitHub homepage, so that we can do some collaborative editing of the drafts, including the you can do either the working group draft or the individual draft there. Next one. So this is the status of the working group right now, and for the first draft mentioned here is the how efficient guidance document. So we have our document Sheffield assigned, and the write-up is ready, and we'll move during and after this session. And for the second one is the crypto draft. This draft has been under review, but we have received some comments, and we are waiting for some decisions on the list to clear up all the issues we found and the concerns of the draft, and so that we can see how we can move forward. And for the co-op draft, this is some ongoing work right now because this draft has actually expired for a while. But I recently go through this draft and really found that this has some important guidance, useful guidance for the implementers. I think this is something that is good for the co-implementers and the community. And then is the TCP constraint network guidance document, which will be presented at this meeting. So next one, please. So this is our agenda today. So we have actually we have received 3 talks, but the third one also has some conflict with IPsec-ME session, so which he could not make it to present at LWIG this time. So we actually have we handled 2 talks today. The first one is the TCP over constraint nodes networks from Canas Gomez. And the second talk is the enable management policy and the guidance for the low power 10 draft, which is a work individual draft from Rahul, Simon, and Yakin. So that next one, please. Yeah.
Then I had a question, like regarding energy efficient, right? Like, so are you going to push the publication request on that so it gets to me?
Yeah, I can hear you. So, so what's your question?
Regarding LWIG energy efficient, the draft, Mohit has done the Shepherd write-up. So are you going to push the request for publication soon, or what's the plan?
Yeah, the plan is to push it to publication.
Okay, sounds good. Okay, thanks.
Okay, any other question from the room?
No, that's good.
Okay, so I think we can. Then, Jim, please help to ask the presenters to the stage.
Yeah, okay, now let's move to the first presentation.
Okay, good afternoon, everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP over constrained node networks. My co-author is John Crowcroft from the University of Cambridge. Okay, thank you. Next, please. Okay, so first of all, let's take a look at the status for this document. The initial version of the draft was presented in Berlin in both LWIG and TCPM working group meetings. So after publication of this initial version of the draft, there was a lot of feedback received, which led to the publication of version 01, which was presented in Seoul. So after that, we received a lot of very good comments from Michael Sharp, who's TCPM co-chair. So the last update of the document is -02, which I'm presenting today. And this version mostly addresses the comments kindly provided by Michael. Next, please. Okay, so first of all, let's take a quick look at the motivation for the draft. So today we have that there are several application layer protocols that are being used for several Internet of Things scenarios. So we have Constrained Application Protocol CoAP, which was originally designed over UDP. However, there's a CoAP over TCP specification in progress, the main reason being the need to overcome problems with middle boxes, which are not so friendly sometimes to UDP traffic. So it means TCP is being used in this case. Then we also have that HTTP 2 and even HTTP 1.1 have been used or are being considered for several IoT scenarios. So TCP is used here again.
Sorry. Is anybody following Jabber? I'm taking the notes, but I hope someone is following Jabber.
So who is willing to be the Jabber subscriber?
Okay. Then we have further application layer protocols such as XMPP, which are sometimes used also in IoT scenarios, and XMPP also relies on TCP at the transport layer. And we also have non-IETF application layer protocols such as MQTT, which also use TCP. So a conclusion here is that TCP is being used or will be used in many IoT scenarios. However, TCP had been quite neglected for IoT scenarios, at least here in the IETF. So the purpose of this document is to offer simple measures for suitable TCP implementation and operation for constrained node networks. Next, please. Okay, so let's go through the updates in this version of the document. First of all, the intended status of the document is now informational. Actually, this is something that had been agreed earlier. However, the change has been applied right now. So it means that the purpose of the document is to report, to explain how TCP can be configured in a suitable way for the scenarios we are considering. Then one section of the document that has been updated is section 2, which is entitled Characteristics of CNNs Relevant for TCP. Here we have added the explicit definition of constrained node networks. This is literally taken from RFC 7228. And the main reason for this is the fact that a reader might have the question, the doubt about whether the guidance in this document applies only to 6LoWPAN or 6Low networks, or which is actually the scope. So the scope of this guidance is any network which conforms to the definition of constrained node networks. Then another section we have updated is the one about the TCP maximum segment size. So in previous versions of the document, there was some recommendations about the fact that some 6LoWPAN or 6Low links define an MTU of 1280 bytes. And then the idea is to avoid IP layer fragmentation. The TCP MSS has to be set accordingly. For example, avoiding to exceed 1220 bytes. However, we have added in this version of the document that there are some further link technologies which are used in the constrained node network space, such as, for instance, MSTP 802.11ah or narrowband IoT, to name a few, which support greater MTUs. So in this case, the TCP MSS may be set to greater values without incurring IP layer fragmentation, although, of course, we have to be careful to adjust correctly the TCP MSS to the specific value for each link. Next, please. Another section we have updated discusses the window size of TCP. So in previous versions of the document, we were actually stating or recommending use of a single MSS window as a way to reduce complexity of the implementation. However, we have modified the approach, the writing of this, and now what we say is we just explain that a TCP stack can reduce implementation complexity by advertising a TCP window size of a single MSS, and can also use a transmit window size of a single MSS. And we explain that, okay, if you do this, then this reduces complexity, but also it reduces performance in some aspects, such as throughput, for instance. So instead of a recommendation, now we have this explanation. Next, please. Another section that has been updated is the one about RTO estimation. So we have added some discussion about the fact that if a small TCP window size is used, then there will be mechanisms such as fast retransmit, fast recovery, or selective acknowledgements, which maybe cannot be used. And that means that the RTO algorithm will probably have a larger impact on performance than otherwise. And that's because retries will be actually triggered by expiration of the RTO. This also opens the door to adapting or tuning the RTO algorithm. However, this has to be done carefully, because there exists some fundamental trade-off behind the RTO, which is that an aggressive RTO behavior reduces the wait times before retries. However, it also increases the probability of incurring spurious timeouts. So this might lead to unnecessarily wasting scarce resources such as energy or bandwidth, which is something that we need to take care about. Next, please. So still in the same section about RTO estimation, we still talk briefly about the COCO RTO algorithm. However, we do it now as a related node. So COCO RTO is the advanced RTO algorithm that's being defined in the core working group for the CoAP protocol. That's defined for operation of a UDP. So the text here is now just as a related node for informational purposes. However, it's probably still beneficial for a reader to find that this algorithm has been evaluated and compared actually with the TCP RTO algorithm and also some state-of-the-art TCP-based RTO variants. And because COCO has been specifically designed for IoT scenarios, it appears to outperform these other algorithms. Then another section that has been updated is the one about delayed acknowledgements. So now we explain, without making particular assumptions about whether some scenarios are more common or not than others, we explain that delayed acknowledgements are not recommended for scenarios with mostly transactional type of traffic, with transaction size of at most 1 MSS. That's because delayed acknowledgements would just contribute delay here. There would be no benefit. And on the other hand, delayed acknowledgements could be useful to reduce the number of acknowledgements sent if an appropriate window size is used in scenarios with bulk transfers. So this could be positive to save resources such as energy and bandwidth in constrained node networks. So one of the changes has been to remove any particular assumption about whether these scenarios or the scenarios are more common than others or not. Next, please. We have also added text to the security considerations section. So there are TCP options that improve security, such as, for instance, MD5 signature option or TCP authentication option, TCP-AO. However, security comes at the cost of increased overhead and complexity. So we need to be aware of this. And for example, MD5 adds 18 bytes per TCP segment, and TCP-AO typically has a size of 16 to 20 bytes. So this is something relevant in the scope of devices which are energy limited, because every additional byte that we are transmitting or receiving is going to consume a possibly significant amount of energy. Next, please. So finally, the document has an annex which has the purpose of reporting the main characteristics of lightweight TCP implementations. And we have added in this version this table that you can see in the slide, which, by the way, is not yet complete. This is in progress, but you can see that the purpose is to allow some quick identification of which are the features supported or not by the different lightweight TCP implementations. And also, the idea would be to collect requirements in terms of memory for each TCP implementation. As you can see also, the sections about Riot and OpenWSN are currently empty. So we'd also like to make a call to the working group so that if anyone is familiar with details on these specific implementations, or maybe someone considers that the table should be expanded with additional lightweight TCP implementations, please get in touch with us and let us know. Next, please.
Rahul Jadhav from Huawei Technologies. In the draft, you have mentioned even the TCP fast open option. And so my question is, are you even considering scope of all the different options? I mean, all the different options which TCP supports as part of this draft, and check whether it is applicable to constrained networks? Like, for example, TCP fast open is mentioned. So, but there are a lot of other variants that can also be, that are also applicable. And along with those applicability comes security considerations as well. So are you going to also take care of those points in this draft?
I'm not sure if I understood correctly what you mean. So, for example, we mentioned TFO as a way to solve the problem that you may have middle boxes in the end-to-end communication. So the idea is, okay, to describe the options of TCP that can be relevant, because someone will have to implement TCP in a lightweight, in a constrained device. So there are several options in TCP. So the idea would be to report the main ways how the TCP implementation can be configured in a suitable way for some specific scenario, which comprises the characteristics of a specific device, characteristics maybe of the network, requirements from the application. So the idea would be to collect the most relevant information, at least from the main options.
So when it comes to TCP fast open option, let's talk about this specifically. So what is the draft considering here? Are we trying to say that TCP fast open option might be more relevant towards constrained networks because sort of sends the data along with the, so what are we trying to conclude there in that?
Well, so the document is informational, so we are not kind of mandating anything. That's a first thing to consider. So the purpose is to explain that a way to avoid having to establish a new TCP connection every time a sensor is sending some data is to use TFO. So you embed data within the SYN packet. So that's a way to avoid this and to avoid the problem with a middle box that you might have in between.
But once we specify the TCP fast open like option, then again the security considerations which are naturally, you are inheriting the security complications as well. Those also have to be specified clearly here. So that would just be as an input from myself.
Yeah, so there's one aspect which is TFO requires some cookie which has to be updated, for instance. And yeah, we might add some details about the refresh rates of that cookie, for example. So yeah, we can
talk about the same point, or?
Yeah, could you go back to the previous slide?
Okay. I think Kerry was before you, so unless you want to talk on the same point, I'll let Kerry talk. Go ahead.
It's just related to what you said. So could you go back to the previous slide? Yeah. So like, if you do security, you need more bytes, but what's the guidance here? Like, should I do this, or should the guidance be that you should anyways have TLS or object security or OSCOP on top of this, and doesn't make sense to do this at this layer? Like, I think the point of the guidance document should be that here are these options, you don't need them because you should have security anyways above. But just the fact that saying, oh, if you do this, you send more bytes on the network, I don't think that's like helps me as an implementer.
Okay, well, thanks for the suggestion. So I think if you can provide input on this, we will really welcome it. And yeah, so the idea is to explain, okay, which are the different options available, which is the impact, and of course, if we can provide options about, okay, if you use something else, maybe it's better, maybe it reduces the overhead, then that's of course beneficial.
So one thing I want to add more like to that is that this is not a working group document yet, right? So like once it becomes a document, then it's up to the working group. Like it's not up to Carlos anymore, right? Like really to see if there's guidance needed or not, right? And the working group decides it's going to go in. That's how I see it. Kerry?
Kerry Lynn. So Carlos, I really thank you for this work. I think it's going to be important over time. I was the author of the MSTP draft that you referenced earlier that has the MTU of 1500 octets. I found out pretty late in the game that, and Eric can correct me if I'm wrong, but if a node supports more than 1280, then it must be able to do path MTU. So I would say that in your document, you should probably provide guidance that unless your application really has a strong reason to have MTUs longer than 1280, you should probably stick with that assumption. Because it wouldn't be, for example, to say here's we're making a lightweight implementation of TCP, but it just pushes the complexity somewhere else. So.
Okay. Thank you.
Hi, Robbie Simpson. So first off, thank you. I'm so glad to see work on TCP on constrained networks. Have you considered adding anything about actual congestion control algorithms, right? So I know most of the world probably looks at new Reno and stuff like that, but there's a lot of intricacies when it comes to congestion control algorithms and potential guidance we could give for constrained networks, and there's stuff even out there that might be more applicable to wireless, et cetera, et cetera.
So the answer would be that not yet. So at this moment, we have mainly been considering a quite binary approach, like mainly influenced because there had been so many claims about TCP being complex and so on, that, okay, we said, well, maybe you can use a single MSS window that reduces complexity, and that has some impact on some mechanisms that will not have any effect. So when we consider a window size greater than one MSS, then all of these effects may come into play. So I think it's relevant also to take a look at those. Yes.
I'm happy to help. I'll be honest with you.
Thank you.
Yeah, my name is Michael Schaaf. I'm speaking as TCPM co-chair. So thanks a lot for this work. I think this is getting really useful. As a TCPM co-chair, I think it's appropriate to this being informational. So I think this is a move in the right direction. And I also want to remind the working group, I mean, if you want changes in TCP, then please come to TCPM. So we own the protocol, but of course we welcome informational guidance in other communities. So definitely this heading is heading in the right direction. I can also confirm that quite a bit of my comments have been addressed. So I think this is really moving in a good direction.
Okay. Thanks a lot, Michael. And as side news, right? So like at the last meeting, so I took an action item on myself to talk to the Transport AD to find like a TCP co-author for this, and thanks to Michael for agreeing to help like Carlos out like with this document. So Michael will be joining as a co-author and help out on the transport pieces of it. Thanks.
Eric Nordmark. So yeah, in addition to confirming the MTU thing, right, that if you send above 1280, you have to be prepared to do path MTU discovery. And if you want to go down that path, I don't know if you want to, but whether one should then recommend to do packetization MTU discovery in TCP, as opposed to relying on the good old, ICMP packet to big messages. I think that,
So you mean 4821, Eric?
What?
You mean 4821?
Whatever the number is, but title is packetization layer MTU discovery, right? So that I think would be good to pick a direction in that space. But the other one that sort of surprised me was this, there seems to be an implicit assumption that the TCP you're talking to is following the same implementation guidelines when it comes to sending with a single packet, right? Having a window of a single packet only makes sense if the party you're talking to doesn't do any delayed acts. And by default, TCP implementations do delayed acts. So there seems to be a strong assumption here that your peer is doing LWIG as well. Because otherwise your maximum packet rate is 1 packet every delayed act timer, which could be 5 packets a second, right? Which is not very impressive, even for a constrained device.
So I think I should double check maybe, but I would say that delayed acts are a should. So
it's not about what you implement, it's what your peer implements, and you can't control that, right?
Okay, then I have to.
Right, both ends are not implementing the same thing. They're both implementing TCP, but there's a wide range of allowed behaviors in TCP, and hence and most likely the peer you're talking to will be not implementing the LWIG recommendations, but implementing standard TCP with delayed acts. So I think that if you only care about sending a packet, a TCP packet once a day, the one packet buffer or outstanding packet is okay. If you want to send 100 packets a second, you have to have more than one, right? Because otherwise you're not going to get any throughput. So, and I think making that more clear, I think that would be good.
Yeah, so we'll take this into consideration. Thank you. Yeah.
Thanks, Eric.
Yeah, so this actually a last slide. So considering that the document is, at least the structure is starting to become stable and even the content itself. So the authors of the document, we would like to ask to the working group whether you think that it is a good moment to adopt the document as a working group document.
So Zen, if you're listening, like, what do you think? You want to do the call hum now and then go on the list, or just take it on the list?
Yes, I'm here. So I think it's based on the feedback from the audience since Berlin. I think it's a good time to ask a polling of this group for some confirmation. But one thing is important that as Michael has speak over the microphone, is we should have some TCP authors also join the work, so that we can make sure that the recommendations in the draft is in the right direction.
Yeah. So Michael is going to help out, right? Like, so to make sure like it's it doesn't like completely go far away from TCP, right? Like plain TCP. So I think so that taken care of is just like a procedural thing. Do you want to do this now or just on the list? That was my question, really. So do you want to do a hum first and then go confirm on list, or do you want to just go on the list and do it after?
I think we can do it right now.
Okay.
So yeah, could you help handle it, because I cannot see the room right now.
Okay, I'll do it. Okay. So how many people have read this draft?
Including me.
Okay. Okay. I think there's not enough people in the room to make this call, but we'll take it on the list. So try to take a look at this draft, and we'll set an adoption call on the list. Okay. Thank you.
Okay, that's fine.
Okay, now let's go to the second.
Hello, everyone. I'm Rahul Jadhav, and the talk is about, the presentation is about neighbor management policies for 6-LoWPAN networks. I think this slide is not the latest one. I mean, this is not the slide that I sent. This is the slide from IETF 97.
Hello, Jen. Yeah, maybe you need to resend the slides to me. This is the wrong slide. It's IETF 97.
So
Yeah.
Do you think I can?
Huh?
Or maybe you can use your laptop.
My laptop?
Yeah.
All right.
I'm sorry, it's my mistake.
Yeah. So all right.
So for people who are following remotely, so there's an older version of the slide that was uploaded to the meeting material. So the author is mailing new slides, and Zen will upload them. So just hold on for a couple of minutes. Thanks. Then can you replace the slide and the meeting materials with the new one that you just got?
Yes, I sent that to Jean. So Jean, could you open your mailbox and see if you got the slide?
Okay, Rahul, I think you need to go ahead with all the slides. Okay, can you do those slides? Yeah, go ahead with those slides. Because the people remote are not going to be able to see it, right? So, okay. Okay, guys, sorry for the people who follow remotely. Like there's been some miscommunication between the presenter and the chair, so we'll make sure it gets uploaded right after the meeting. Okay, thanks.
By any chance, anyone knows how to change the screen to the projector? Sorry? No, we just project yours. Both of them? Yes. Thank you. And sorry everyone for the delay. So this work was presented in IETF 97 in Seoul, and the idea is about neighbor management policies in 6LoWPAN networks. So during the last talk, there was no draft. So we tried to get a general feedback from the working group whether it makes sense to work on this problem statement, and we got an enormous response, post which we have a draft now, a working draft. We have an individual submission here. So yeah, can you get it to full screen and then Control L? Sorry. Yeah. So what has changed since then? First things, in the last presentation, what we had done was we had presented a policy, a neighbor management policy. And what has changed since then is, apart from the policy, the signaling considerations, the signaling recommendations as to how to bring this policy into effect has been taken care of. So let me begin. Some of the slides I'm going to repeat here. The neighbor management, why neighbor management is required. So in case of 6LoWPAN networks, it is difficult to anticipate the maximum density of the nodes in a given network. So how much of the table space do you allocate for the neighbor cache? So that is the primary question that has been. So whatever cache size you allocate, at some point of time, if the density is very high, it's going to overflow. So in that case, how are you going to handle what are the entries are you going to retain in the neighbor cache? Now, prioritization based on the link quality estimation doesn't always work. In some cases, you might have to retain the cache entries which are more relevant. For example, it might not be advisable to evict an entry based on the direct child, a routing child. So because what happens is it has a ripple effect in terms of all the grandchilds are also evicted. So there are some implications in terms of which entries you can evict from the table. So there are some trivial neighbor management policies. One of them is LRU, another of it is FCFS, first come first serve basis. Both of them have significant disadvantages, and none of these algorithms will scale. Unfortunately, these are the algorithms that are currently implemented in most of the open sources. The final expectation of this neighbor management policy is that it should result in a stable network. So when I say stable network, the routing adjacencies should not change periodically. I mean, without such a neighbor management policy, you will have a lot of churn between the neighbors, and you won't ever get a stable routing adjacencies. Another thing is, once the neighbor is accepted, it has to be guaranteed that all the associated resources are present to serve that neighbor. So in the adjoining diagram, if you see there, what is mentioned is there is a heavily lopsided network in the first place, and with the neighbor management policy, it sort of load balances the overall network. Now, one of the things that we took into consideration while putting up a general guidelines is this guideline should be protocol agnostic as far as possible. We didn't consider Ripple specifically or any key management protocol specifically, but we had to take some examples. So as an example, we have taken Ripple and both of its mode of operations, and PANA as a key management protocol. Next slide, please. So we have considered a holistic approach towards neighbor management. When I say holistic, apart from the routing protocol, we also consider the key management, the initial key handshake procedure. Now that has serious implications on the neighbor cache management. So that is why it has to be taken into consideration. So in the sample example network that we have, it's a PANA-based key authentication protocol, key management protocol, which is what Wyson has mandated. The draft also explains the different network management when it comes to RPL, what are the different options available, how to serve the different mode of operations for Ripple. So now what are the cases in which the neighbor table update happens? So first case is during initial key authentication, the relay element has to be selected. Now there is a relay element discovery here, PANA relay element discovery. So you need to, so when that discovery happens, the PANA client has to make an entry on behalf of the PRE. The PRE has to make an entry on behalf of the PANA client. So this is the signaling that is involved. So subsequently, once the authentication is finished, then the RIPL comes into picture. There's a DIO messaging. There will be a parent node entry. There will be a routing direct child entry. So in the example that you've seen here, if you see the P3, the node N3 has two routing parents and one routing child and one authentication session in progress. One more important thing while working on this draft that we had come across is the implicit versus explicit signaling. What I mean is, in case of constrained network, you don't want to add additional overhead in terms of NS and IPv6 NDP procedures. So as far as possible, if it is possible for you to add the neighbor cache entries on behalf of existing signaling, then that has to be used. So this is the signaling recommendation as part of this draft. So when I say implicit signaling, what I mean is the neighbor cache entries can be added as part of RIPL signaling or as part of PANA discovery signaling. In certain cases, it is not possible. For example, in case of RIPL's non-storing mode, it is not possible to make such an entries, in which case you have to work out a solution based on IPv6 NDP. IPv6 NDP RFC 6775 already defines a procedure wherein you can send an NS with an ARO option if required to register an entry, to register a neighbor cache entry. Next slide, please.
Mohit, just a quick comment. So in 6 law, there is work on neighbor discovery for constrained networks. So it would be good to see how this relates to that work. There's work on lightweight neighbor discovery, secure lightweight neighbor discovery. I think it will be presented in the 6 law session. Is it tomorrow? So it would be good to know how this relates.
Yeah. So there are two considerations for this draft. One is the signaling considerations and another is the policy. How do you actually populate the table? Which all entries, how do you retain the entries? Which all entries do you give the priorities? So the signaling considerations, we are not adding any new signaling here. We are as far as possible depending upon the existing specifications from 6 law working group towards doing the signaling. But in certain cases, we are recommending certain things. For example, in case of RIPL, if you directly use DIO DAO messaging to populate the neighbor cache entries, then there is the additional overhead of IPv6 NDP messaging is saved. So these are so this is how it relates. So what are the different neighbor management operations? So there are 3 primary operations: the insertion, eviction, and the reinforcement. So as part of insertion, if there is a simple logic, as in if the table space is available, insert. Now this is the policy that is by default used by most of the operating systems. So the major problem with this particular policy is that in case of RIPL, there is a multicast DIO that is sent. Now if all the nodes are going to add a neighbor cache entry based on this DIO, then it's going to overflow. The table is going to overflow with all the parent entries. Similarly, if the same parent is chosen by all the child nodes, then the same parent will have all the DAO entries coming to it, and the neighbor cache entry will be overloaded with the routing direct child entries. Similarly, for PRE discovery, it is the same procedure, just that the stage is different. In case of eviction, like I mentioned, in case of eviction, if a routing child is evicted, it not only impacts the routing child, but it also impacts all the subsequent grandchilds, because in case of storing mode, all the child goes via the same parent. So it not only impacts that child, but all the complete subtree beneath that child. Now, one of the important consideration here is if you see the point where evicting non-preferred parent NC. Now, evicting non-preferred parent neighbor cache entry is usually possible without much implications. What I mean here is, if there are 10 parents to be that are available in the table neighbor cache entries, then it is possible to evict one of the parent entries and make space available for some other. So my point is, you can easily evict a non-preferred parent NC and make the space available for something else. So now this is one of the considerations that we make use of when we apply the policy. Now, what is next? The reinforcement. The neighbor cache entries are going to be present in the table for quite some time. So the link quality estimation has to be done on the periodic basis. The draft does not make any, the draft does not define any specific procedure on how this link estimation is going to be done. This is implementation specific. The reinforcement part is mentioned here just for making sure that all the nodes have to, all the implementations have to consider some sort of reinforcement policy. For example, it might be a passive or active hearing, or it might be explicit probing, which is done by Contiki, for example. Next slide, please. Now, clearing unused neighbor table entries. Now, this is again important, and in case of constrained node entries, this is constrained node networks. This is especially difficult because there is no explicit signaling when a route changes, for example, or even if the route changes, if there is an explicit signaling involved, for example, in the form of NP-DAO, it is easy to get. I mean, it is not a very deterministic way of clearing up the entries. So the point here is route invalidation is especially important, and if there is an optimized route invalidation procedure, only in that case you'll be able to clear up the unused NCs. In case of non-storing mode, now this is especially important because in case of non-storing mode, there is no NP-DAO. There is no NOPAD DAO involved. So how do you clear the entries? In this case, we have recommended making use of NS with lifetime of 0, which is as per RFC 6775 IPv6 NDP procedures. In case of PRE, now the PRE is an element which does not keep any state information on behalf of PANA client. So how do you clear the entries? So there is no way except that unless and until there are some clues available as part of the authentication procedure, but since PRE is completely stateless, there is no such kind of clues are not available. So the only way, one of the way to evict the entries as soon as possible is to keep a different lifetime for such entries. So you might have a lower lifetime for such authentication entries. Next slide, please. Now, this is one of part of the recommendation that is done by the draft. What is the signaling? What is the signaling used for neighbor entry management? So, if you see, there are 3 flows that are specified here: PRE discovery, storing mode of operation,
Rahul?
and non-storing mode of operation.
Rahul, yeah. I think you need to wind up.
Sorry. Okay. So, basically, what it says is that there is a way to do an implicit signaling as well as explicit signaling. In case of non-storing mode of operation, there is a requirement that you do an explicit signaling in the form of NS with ARO option. While in case of in case of storing mode of operation, you can depend upon DIO and DAO messaging. In case of PRE discovery, there is an unsecured NS for which you get an unsecured NA. So there is a difference between what kind of security is available at which stage. Next slide, please. So the sample policy, now this is one of the critical point here. The sample policy is based on reservation. So you have a table space, you make a reservation for routing direct childs as well as PRE authentication sessions. Now, if the parent elements can be occupied, the parent elements can be filled up in all the places because it is possible to evict those entries if required. So the point is that the table space will be properly utilized in case routing childs are not available or authentication sessions are not available. One of the things that is mentioned on this slide is about the graceful rejection of DAO and PANA messages. So in case of implicit signaling, it is important that there has to be some sort of rejection mechanism available in the signaling. For example, if you send a DAO, if the table is full, there is a DAO with negative acknowledgement present. But similarly, in case of PANA signaling, such a negative mechanism is not available. This negative signaling is not available. So you can't really use PANA discovery as an implicit mechanism for signaling. Next slide, please. Yeah, some of the issues that we have faced is, now this is a reactive policy. You send a DAO, you send a NS, and then it gets failed. But what happens if the same for example, if a parent notes neighbor cache is full and it sends a DIO, there is a good chance that some other child might come up and select that node as a parent. So how would this child node come to know that the parent does not have enough space available? So currently there is no way to know this, because this is currently it's a reactive policy. So what we are recommending here is there might be some solution possible based on a proactive approach. For example, the NC, the neighbor cache entry metric, has to be advertised as part of DIO. Hello, is this working? Yeah. The NC metric has to be advertised as part of DIO messaging. Now, one more important thing here is that this proactive approach applies to not only the REPL protocol, but as well to the PANA discovery messaging protocol. Now, the metric containers that are available with the REPL has to be shared between PANA discovery messaging as well as REPL. Anyways, currently, based on the, there's one question that is asked here: can REPL metrics containers be reused by another protocol? And I don't see any reason why, but I would like to take an opinion from the working group. If someone else thinks that it cannot be reused, then we would like to know. Next slide, please. Yeah, so basically, there are some questions that we have asked here. Should we consider a signaling extension for proactive mode? Not as part of this draft, because this specifically is a guidelines and policy draft. And secondly, we have a question regarding how do other implementations take care of finding out or discovering how would the parent node come to know about the global IPv6 address of the child node, which is required for resolving the SRH header. So these are some questions that we wanted to ask the working group if there are any implementers available. And call for, yeah. So
lots of information. Samita Chakrabarti, 6LWIG co-chair. So I figured that in this document or proposal, you have multiple solutions put together in one document, especially one with REPL or pure NDP or with PANA for distribution of your NC parameters. To my mind, I'm not 100% clear about the charter of LWIG, but I'm thinking it seemed to me that it could be divided into different pieces. Like I don't think you can implement it without any changes in either 6LoWPAN and neighbor discovery or role. So I would say you have to probably present in respective groups and get some buy-in, because I see there are some other work also going on, yeah. Especially I know in 6LoW, so how it was mentioned by Mohit before as well.
So this is what we have thought about it, and please check if it makes sense. So as part of this work, we are considering only the implementation guidelines, and if there are any extensions that have to be done, then we go about according to whatever the relevant working group is. For example, in case of if the proactive approach has to be followed, then we go with the role working group. Or if there is any signaling change for that matter somewhere else, then we go accordingly with that working group. So as of now, this draft does not make any. This is an informational draft.
I think we're out of time. So I think it's good, Samita, that you have this conversation offline with them, and you can continue on the mailing list, sure. And then we figure out like how to do this logistically. Okay? Sure. Thank you very much. So,
thank you.
Thanks a lot for waiting and putting up with the the slide stuff. So thanks a lot. So have a nice evening. Thanks, Zen, for staying up late.
Yes.
Bye. Yeah.
Thank you so much for Srish and Jing. And have a good evening, everybody.
Bye. Take care. See you soon.